Hello and welcome back, my dear students. In today's lesson, I'm going just to cover section 12.1 about functions of several variables. This is a very important part of the multivariable calculus. What do we mean by functions of several variables? What you used to study in your Calc 1 courses at the school, the functions that you were introduced to before, they were all function of one variable. So you know that you have a function, this is what you used to take. So it's a function that's basically a mapping from x to y, and you used to write y equals f of x. This is a function of one variable. If you see here x, f of x, I have only one variable for the function f. And this function is basically takes the numbers from real numbers and takes them back to real numbers. So it goes from real numbers into real numbers. Now, if I need to expand this concept into two variables for now, if I think about two variables, then I'll have an order pair. It's not only x. I'll have the order pair xy goes to what? To f of xy. So basically, it's just like I'm taking from the domain in the two-dimensional space in R squared, and then the range will be what? A real number. So you're having an order pair, the range will be a real number. Now, for examples, if you think about some examples of f of x of y, we usually, this is the notation we're using. So before you used to write only f of x, now we have to write f of x, y. This is a function in two variables. What could be the example? Anything involves x and y. So we could have, for example, xy squared. We could have gxy equals x squared minus e to the power of y. In any order, by the way, here. It's not necessary that you write x first. Any function involves x and y. This is what we call a function of two variables. Now, can we have any function in three variables? Yes. In four variables? Yes. It's of several variables. But for the purpose of this chapter, we're going to just do only two and three variables. If it's a function of three variables, then I'm not going to have only order pair. So this is now order triple. And the order triple is basically like x, y, z in the three-dimensional space. So we have the domain in R cubed, and the range will be where? A real number. So like, for example, I could take a function like f of xy, z equals xy squared cosine z. It's a function and it has three variables. Same thing here. gxyz equals 3z x squared minus e to the power of y, in any order, but I have all the three variables. Okay, now our main concern in this section 12.1, we need only to concentrate on finding the domain for these functions. So to find the domain for this function, to describe it or to sketch it, what you need to do is just something similar to what you used to do. So you need to deal with the functions separately, the one for x alone, the one for y alone, and see what's the domain, where do we have issues. We know basically what are the most important things that we usually see with the domain. The domain in general, we assume it's all real numbers, okay? But if we have any restriction, like something you have a over b as a fraction, we know that b can't be equals to 0. If I have a square root of a, so I know that a should be greater than or equals to 0. If I have, let's say, log or len, they have the same thing. If I have log a or len a, I know that a should be greater than 0. These are some of the famous functions that you need to consider when you take or find the domain. What else do we know? We know that polynomials, they are defined everywhere. So the domain for them is basically, domain of all polynomials is the set of all real numbers. If I have sine and cosine, sine of x and cosine of x, their domain is again the set of all real numbers. Okay, so there's some group of functions that you have to recognize directly once you see them. Let's see what do we have, and then we consider these cases one by one. We can deal with any issue raising while we're solving. So now for this specific function, what do we need to do? They ask us to find and sketch the domain for this function. This is a function into two variables. I have it as x len of x. Remember, always to find the domain, we're looking where do we have an issues. So the domain basically is where x has an image. All the values of x and y that they have a corresponding image in the function. So if I think about x, is there any value for x in the real number that I'm not allowed to substitute here? It's all okay. This is basically a polynomial. So its domain is all real numbers. So I have no issue with x. Now moving to len. Remember, as I just said, with len, log, I need always to know that y should be greater than 0. So now what should be the overall domain? R doesn't affect the domain, so I need to find their intersection. So the domain for x is the set of all real numbers. The domain for len of y is y greater than 0. So the overall domain should be what? Y greater than 0. Okay, how do I graph this domain if y is greater than 0? This is the xy coordinate. If I say y greater than 0, so where do I have to shade? Which area? Y greater than 0, so this is the right hand side of the y-axis. Right? This is where the y is greater than 0. Or I have to put above the x-axis. What do you think? Where do we say that y greater than 0? Yes. So I need to consider all the points where y is positive, which is the positive y-axis. So it should be above the x-axis. So anything above the x-axis is part of the domain. Can I include the x-axis itself? Remember, what's the equation of the x-axis? Y equals to 0. What's the equation of the y-axis? It's x equals to 0. So when I say y greater than 0, so it's anything above the y-axis, above the x-axis, not including the x-axis itself. So I need just to, how do I show that it's not included? You use a dashed line. So this axis is just dashed line, and then the domain will be everything on top or above the x-axis. So I need just to shade this region. So it's basically region 1 and 2, excluding the x-axis itself. So this is our domain. I need to shade everything. All of this is included. Okay, hopefully the idea is clear. So you need just to consider them one by one and see what's the restriction, what should be the domain. Now, let's try one more. This one. Gx of y equals 2x over y minus x squared. If I look at the numerator, this is basically a polynomial. It's defined everywhere for all real numbers, no issues. Now down, it's okay. It's still y minus x squared. It's defined everywhere. But the only issue here that it's located where? In the denominator. And I know anything in the denominator can't be equals to 0. So that means y minus x squared can't be equals to 0. And when y minus x squared does not equal to 0, solve this. So y can't be equals to x squared. Elsewhere, it's okay. I have no issues. My issue only when y equals x squared. Okay. What do we know about y equals x squared? How does it look like? It's the parabola, right? I have y equals x squared. It's the parabola. Okay. Let's try to graph the parabola y equals x squared. So the vertex is at 0. We know it's concave upward. So let's take some point. It's 1, 1, 2, 4. Yeah, approximately. And it's symmetric to the other side. And let's graph our parabola. If I need it not to be included, then I have to do it what? Dashed curve. So it should be, I'm just doing sketching. So the x squared should be dashed curve, because it's not included. This is the graph of x squared. Now what should be the domain then? Everything else. So if I need to highlight, I highlight everything except that curve of y equals x squared. So everything is included, even inside here. So this is all included except y equals x squared. This is the only part excluded. So any points on the y equals x squared, it's not part of the domain. Okay, let's say that's it. Just like I've shaded everywhere. Fine, except at the graph itself. Okay, so hopefully the idea is clear. So you need just to consider the domain and then graph it. If there's anything excluded, that's when you graph it as dashed curve, dashed point, dashed line. So it depends on the curve. Now for the three-dimensional space, I'm not going to ask you to graph them, but what's required here is just only to describe the domain, okay? We need to describe the domain as a graph. It looks like what? But no need to graph it. So let's just deal with these three variables function one by one. Let's start with this one. I have f of x, y, z, and it's equals cosine x plus z over xy. Now let's deal with them one by one. I'll think about the numerator. The numerator is basically cosine, okay? And we know the cosine. Inside I have x plus z. Both have no issues, defined everywhere. Cosine also defined everywhere. So the domain for the numerator is the set of all real numbers. I have no issues. Now for the denominator, x alone has no issues, y alone has no issues. The only issue that they are located in the denominator. So xy can't be equals to 0. So xy, we can't have it equals to 0. Okay. If xy can't be equals to 0, what does that mean for us? Like if I think about the algebra, what do I have? So how do I write the domain? So the domain should be the point x, y, z, where x can't be equals to 0 and y can't be equals to 0. Right? If the multiplication does not equal to 0, then both of them, they shouldn't be equals to 0. X can't be equals to 0 and y can't be equals to 0. If any of them is equals to 0, then their multiplication will be 0. So both of them should be does not equal to 0. Remember the 0 property? What does the 0 property says? If you have AB equals to 0, then it's A equals to 0 or B equals to 0. When we do the negation that it does not equal to 0, so what does it imply? That A does not equal to 0, B does not equal to 0, and what's the negation for OR? It's AND. You see, this is like the basic logic I always tell you about. When you deal with anything in math, you need just to work with logic. This is a logical statement. Okay, 0 property, this is the negation of the 0 property, so it's now AND. Anyway, so clearly I can't have x equals to 0 or y equals to 0. Now, how can we describe this domain? What can we say about this? This is what can we say. So if x, y, z is order triple and x can't be equals to 0 and y can't be equals to 0, how can we describe it? We can say that the domain is the set of all three-dimensional space excluded the, notice if this does not equal to 0, x does not equal to 0, it means what? Excluding the yz plane. This is where x equals to 0, the yz plane. Excluding the yz plane and the xz plane. So remember always, if x is equals to 0, this is basically the yz plane. If y is equals to 0, this is basically the xz plane. Always take the missing variables. This is the easiest way to see it. So if y equals to 0, then this is the xz plane. So how do we describe the domain? We say that it's all the three-dimensional space excluding the YZ plane and the XZ plane. How do we write the domain? This way. If I need to describe it, this is what I do. So if we need just to rewrite the domain in the previous questions, it's in the same format. So here we say just that x can't be equals to x squared. So it's all order pair except x equals to y squared. Okay, now let's think about this one, the last one. I have gxyz equals square root of 9 minus x squared minus y squared minus z squared. Okay, interesting. How can I deal with this? Now, under the square root, what I have, all of these are defined. We have no issues as the function inside the square root. My issue is basically with the square root. What do we know about the square root? We know that anything inside the square root should be greater than or equals to 0. Okay, let's write it down. So I'll say 9 minus x squared minus y squared minus z squared should be greater than or equals to 0. Let's have all variables in one side. So it will be x squared plus y squared plus z squared. I'm moving all variables to this side. Less than or equals to 9. Okay, this is the domain. Now, what does this equation remind you of? It has three variables, x squared, y squared, z squared, equals to 9, let's say, if it's equals to. This is the equation of sphere, right? This is a sphere equation with center 0, 0, 0, the origin, and radius equals to 3. Then what should be the domain in this case? So I can describe the domain as the sphere. Let's use another color. So it's, the domain is the sphere of, what did we say, the radius? Radius equals to 3, of radius 3 centered at the origin. Okay, so I know now it's an equation of a sphere. So x squared plus y squared plus z squared equals to 9. This is an equation of a sphere. Now this is less than or equal. Less than, that means inside the sphere. So if I have a sphere, okay, think that you have a sphere in the three-dimensional space. Assume something roughly like this. So if I have the sphere, then the domain will be inside the sphere. And what about the exterior part of the sphere? So the interior is included and the sphere itself also is included. So this is centered at the origin together with its interior. So the sphere, the outer part, this here, the sphere itself including its interior. So together with its interior. And this is the domain. Okay, we have the sphere itself together with its interior. Now I'll give you another question to think about, something similar to this, little bit. So let's say we have, I'm not gonna just change the slide, but assume that I ask you to find, this is for you to think about. Think about what? Let's say I have the function as f of xy equals 1 over square root of 9 minus x squared minus y squared. What do you think the domain should be? 1 has no issues, okay? Down you have square root, so whatever under the square root, if it's in the denominator, so this is strictly greater than 0. So it's greater than 0 but without equality. If you solve it exactly the same way, so you'll find x squared plus y squared is less than 9. So if I need just to describe this domain, So it should be, the domain should be the circle of radius 3 centered at the origin together with its interior, or the interior only. What do you think? There's no equality. So how can I describe it? I'll say the domain is the interior of the circle of radius 3 centered at the origin. If I need to graph it, just as we did before, so I'll graph the circle. Let's say that it has center 0, 0 and the radius 3, 3, 3. So the graph should be a traced dashed circle, and where should be the domain? Anything inside that circle. So the domain should be just only the interior part of the circle. You see, so that's why sometimes you learn something, but if you have any similar question or close to, you can do exactly the same thing. Fine. So here I'll say again, the domain is the interior part of the circle of radius 3 centered at the origin. Why I didn't take the circle itself? Because it's excluded. There's no equality, so it's only the interior part. What about if I have it greater than, by the way? Let's say it was greater than 9. So it should be what? Everything except the interior part of the circle. So you need just always to consider these shapes that you have. These are like famous ones, circle, sphere, you should know them. And that's it about 12.1. It's very simple, short one, easy one to deal with. So take care, and next time we'll move to our last section, which is 13.1.